Okay, give me a second then. I don't think, I suppose the deadline for week 9 is due tomorrow. It has to be submitted by tomorrow, right?
No, it
No,
passed
it's already
tomorrow.
submitted.
It is already submitted.
It's over yesterday.
Yeah.
8th August, 12 o'clock night.
Give me a minute then.
If you do week 9, no problem. But week 10 summary, if you give, it will be very helpful because not only data submission exam is coming from week 1 to 12 whole, and this week 10 is actually
Only 4 days
the
are
portal
left.
lecture difficult to understand since it is completely new.
Yeah, and only 4 days are left for the submission.
If you do week 9, that will be also revision good, no problem. But week 10 also, if you give a summary explanation, it will be helpful.
Yes, ma'am. Please give summary of week 10.
Okay, so take the summary session for week 10 in some time, but I think that we should still give that. I just want to make sure that there's no doubt from week 9 for anyone. There's no doubt from anyone here.
I have doubts from week 9 graded assignment.
So,
But we can start week 10 and then after doing week 10 summary, then we can go to doubts of week 9.
Yes, ma'am. We can start week 10.
Yeah, because the assignment is over already and week 10 we are having issues.
okay, so we'll take the summary of the doubt for the week 9 towards the end of the session, if that's okay with everyone. And we'll start with the week 10
Sure.
summary.
Ma'am, can I ask you a
Ma'am,
quick
is,
question? Sorry.
Is Riemann sums related to like week 10? If not, then we can directly proceed.
No, it is not
Oh.
related to week 10.
So it's
Okay.
week
10
9.
has graph theory.
Riemann sums is week 9.
Sorry, what?
Riemann sums is in week 9. It's a part of week 9.
It-
Yeah. I have doubt in that, so I was just clarifying whether it's also coming in week 10.
No, it is not related to week 10. Week 10 is graph theory.
Okay, so
Okay.
Yeah,
let's do the week 9 doubts first. I don't think there are a lot of doubts from there. We'll just quickly get done with them and then we'll start with week 10.
I had a quick
think we
question.
won't be, yeah.
See, I got a bit mixed up with the dates, and I missed the assignment yesterday. And is that going to be a problem?
So are you planning to submit it now?
It's a bit late, right? I mean, I can't. I don't think I'm allowed to submit it anymore.
I don't think so.
Yeah, but is that a problem, or as long as your scores are fine, you're fine?
It's not a problem related to your end term, but yeah, your score will go a little down because 10% is consisted of GS.
Okay,
First 10 weeks.
and the 10% is like a average of some 7 of the scores that you've done, right? So it shouldn't
No,
really
it's
matter.
it's like 10% of the first 10 GS. So your percentage will go down by 0.01%. Not
Okay.
0.1, 1%. Yeah.
This can be
All right.
discussed in chat, I guess.
Sure. Sorry about that, ma'am. Thank you.
So we're starting with the week 9 doubts then. And I'll just share my screen. Yes, so let's go with the doubts for week 9. Whoever has a doubt can ask in whatever week, whatever
Activity
assignment.
9,
Okay.
activity 9.6, 5th and 6th question. Sorry, 9th and 10th question. Sorry, sir.
So 9th and 10th from 9.6.
Yes.
We've been given 2 graphs. The area which is enclosed by the curves f1x and f2x. And you need to find the area between these two curves, right? So this is how it roughly looks like. And then there's this one. So you know which one's which, right? This one is,
And without drawing the graph, is anywhere possible finding the area? Just
you
asking.
need to know which one to minus from which one, right? So what we do here is, so when we take the integration part, there's this function say. So what we mean by this is, let's just say this is the fx graph. So we mean we're taking the area from x equals to this. These are the limits of x because you're integrating with respect to x. So this is it. This means you're taking it from
Is
a
this
to
session recorded?
yes.
I think recording is not started.
No, Neil, this is a Zoom meeting, so you can see in the YouTube.
Yeah.
This is not a Google Meet.
So this would mean that this is so if this is your function fx and this is a and b, say, so this is your area, right? So you need to know, so to know the area between these two things, what you do is you take the area of this graph under this graph and then you subtract the area. So you need to know which one to subtract from which one. So is it f1 minus f2 or f2 minus f2? But if you have that, if this actually is it won't really matter. It would just change the sign of these. One would be the negative of the other one. And if you have, say, 6 area, then you would have minus 6 here. So if this graph was actually on the upper side and this was on the lower side, then you know that the area should be 6 plus 6. If it's minus 6, that means you've taken the order wrong. Is that okay? Okay, so your 3x square, so this is your 3x square and this is your 4 minus x square. So to take the area, we know that this graph is the upper one. So we'll take 4 minus x square here and then we'll subtract this thing from here. And then we need to find the point of intersection of these two curves. So we need to find a and b. So we'll take 3x, equate 3x squared to 4 minus x squared. So you get a 4x squared, this thing you get. So this is plus minus 1. So this is minus 1 and this is 1. So we take the limit from minus 1 to 1. And this is 4 minus 4x.
Excuse me, ma'am. Sorry to interrupt, but ma'am, I am not getting how did you find that F2 is greater than F1?
See, you have two curves, 3x square and 4 minus x square. So how do we plot parabolas or anything is, so if you have y minus, you must have done this. And if you haven't, then let me just tell you this thing. If you have y is equal to fx, some standard graph like this one, this is a graph of parabola, which looks like this thing. If you have this thing, there are some operations here. What will happen if you take x minus a? What will happen if you take y minus a? What will happen if you take a negative sign here, a negative sign inside this in the argument? So if you know all that, you'd be able to plot this thing. So this thing or even this thing looks like this because it passes through 0, 0. You've already been given two curves, right? And the other one is 4 minus x. So this is definitely 3x square because it passes through 0, 0. This curve. And the other one obviously has to be 4 minus x square. That's how you know which one is the upper one and which one is the lower one. And
Okay,
you should
ma'am.
subtract, okay. You should subtract the area under this curve, the area under this one, this curve from the area under this upper one. That's what we are doing here. This thing. Then it's just simple integration. So I think everyone can do the integration part. We need to do it here.
Ma'am, can you guide us a bit on integration because you're not so I'm not so well versed with it.
Yeah, sure. So should I just write down the basic formulas for integration if that's okay?
Yes, ma'am, that will help.
I think they have already been given in the graded assignment, somewhere in the questions only. But we'll just quickly go through it. So starting off with polynomials, if you have a polynomial, if you have anything of the form x to the power n, the integration of it is x to the power n by n plus 1. You're familiar with the derivatives, right? So if you know the derivatives of some basic functions, then it will be easier to integrate. Should I write them down too? Do they need to be
No,
written
ma'am,
down?
derivative
Okay.
I'm aware.
So okay, the integration is like the reverse of it only. So if you have, if it's given secant square in the integral, then it's tan. This is tan, right? It's just because the derivative of tan is secant. So that's how you do it. If you remember the derivatives of some basic functions, you'd know the integration of these things. This one thing, then this is this thing. These are the ones that you likely see in your assignments and everything. EX integration is EX only. And AX's integration is AX by natural log of A. And there are other things too if you want. There are these functions. I don't think there's a lot of questions based on these ones, but this is it.
Excuse me, ma'am.
Yes.
Could you please show the just one thing integration by part in which there is if a function e to the power x something means I had actually forgot about it a little, but if you just give a hint, I will be able to catch it. Means there is a type of function in integration by part where e to the power x into something, there is a direct formula or a direct approach.
Okay,
In
to the power
one or
x.
two questions, it is requiring. So I said.
Is it this or something similar? What is it? I'm not sure what you're talking about. You can just use integration by parts if there are two functions there.
These standard ones, is it important to somehow memorize them, or is it easily possible to derive them?
Yeah, it's easily possible to derive them too. Let me just do it for this one. When you have tan x, you write it as sin x by cos x. And then you can just use substitution here. You're basically doing this thing. You got to write the dx here. So what you do is, this is cos. You substitute cos x equals t. and then you will get a t here, and you get a dt here, actually a minus dt, because this will be, if you take the derivative on both sides, you will get this thing, dt dx minus. This is what you get, right? So this is it. This can be researched. And please don't forget to change the limits here. So if there's something in the limits, the limit needs to be changed accordingly from this expression. Then you know
And
how to
could you
solve
please
it.
zoom out so that I can see the standard formulas? I will just take a screenshot. I actually frequently forget, so I need to.
So, ma'am, I have a very basic question. So, you do dt by dx, is it? Is equal to minus sine x. Is that how you get it?
The substitution part.
Yeah.
Okay, this is t is equals to cos x. What you do here is you differentiate both of these. So you differentiate t, you get a dt here, and then you differentiate this thing, you get a minus sine x and dx. Is that okay?
Yeah. So when you differentiate t, you get dt by dx, is it?
The dx is carried forward.
Yeah,
to
that's what it is.
Okay.
It's dt by dx, because you're differentiating this with respect to x and this with respect to x.
Okay.
But eventually it gets to that side. So
Sure.
Excuse me, ma'am, could you please just zoom out so that I can take a photo of the
you want the formulas, right? I'll write them
means
down.
for I want means these are the formulas I frequently either forget or mistake in some mix up with other formulas. So I want to.
Yeah, just write them down in one place. Don't mind.
Now, could you please just zoom out means so that they fit in? Okay, thank you.
So this is so obviously you can derive them using the sine by cos or by writing them in sine and cos forms, but then it's not very ideal. If you can remember them, it's easier to solve questions.
The cortex, is it natural
this is-
logarithm modulus sine x, or is
Yes,
it a
this is obviously modulus, because you can't take negative in the argument of log, right? So
okay.
modulus. And then these are like the ones that you can use quickly. You won't have to go through the calculations. And then there are some identities too that you can use.
Ma'am, the
Yes.
last one, can you just read out? Is it?
Okay, I'll just write it down clearly. Is this okay now?
Yes.
Okay, and then just write down some other important things too. So familiar with the inverse ones, right?
Yeah, that's one thing I had a question on.
Okay, inverse ones we'll write down. We'll first just okay, I'll just write down the derivative of inverse functions so that whenever you see these in the these are derivatives, not integrals. The other ones are integrals. These are integrals. For sine inverse x, it's 1 by this thing. For cos inverse x, it's the negative of this one. Okay, we don't have enough space here. I wanted it to fit in so that it's in one place. You just write it.
Excuse me, ma'am.
Yes.
Could you please also remind about the process of integration by parts? Just in brief.
What?
Could you please?
Yeah, integration. We'll do that too. Okay.
Integration by parts. Not
Yeah. That's what I'm talking about. Wait. And what were we discussing? Yeah, the derivatives of inverse functions. So for sine inverse, I'm not writing the argument, it's x. So it's this thing. Just write it down to this. Wait, give me a second. And then we have cos inverse x, which is the negative of this thing. Tan inverse is this thing. And cot inverse is exactly the negative of this.
Ma'am, I have one very basic question. Ma'am, what are this inverse function? Is it like sine inverse x means 1 upon sine x or
It's
something,
just the
or both?
inverse of. So you do know what inverse of a function is, right?
Yes, ma'am,
So
inverse
cos
in
inverse
general,
is
yes.
the inverse of cos function.
Ma'am,
It's the
in
inverse
terms,
function.
okay, ma'am, in terms of trigonometric functions, I've never visualized what their inverse function look like. Maybe I'll try that my hand on.
Okay. And then secant left, right? Secant inverse. This is this thing. Then cosecant inverse. I don't think you'll need all of these. One are not usually there, so you won't see cosecant and secant. But it's better if you do remember them. This one is negative of this. They're all negative of something else. These two are negatives of each other. These two are negatives of each other, and then these two are negative. So if you see something like this in the integration, this thing, so it's sine inverse of x plus obviously a constant. And if you see a square minus x square instead, so this you can do manually too. Don't need to remember the formula, but it's always a good thing if you remember the formulas. Then you don't have to do the calculation part. It's a dx everywhere, even if I skip it somewhere. So this is, I think, sine inverse of x by a plus a constant. So just what you can do is you can divide this whole thing by a square and multiply by a. So multiply this by a. If you want to derive it, you can derive it. And multiply this thing with a, and then you can divide here in the square root by a square. So that's how you can do it. And if you similarly, if you see this thing a square plus x square, it looks very similar to the tan one.
Inverse x.
It's not tan inverse x exactly, but it is derived from there only. So it's this thing. It's this. Give me a second.
Ma'am, in the middle one, right now what I can see, integration of in the denominator is written under root a square minus x square. The answer is sine inverse x by a plus c. While the same thing is written in plus in the last one, then we have additional 1 by a in front of tan inverse.
That you know when you substitute it.
Okay.
Try doing this thing. What you do here is just divide this thing. What you can do here is this is a square minus x square.
That is the formula that came out
This
from the derivation.
a square, and you multiply here with an a, so that nothing changes. And then you just do one thing, so you get a 1 minus x square by a square. And then this thing is, you substitute this thing. Or substitute this thing as t square, because you need a t square. You know the formula of 1 minus t square. Then you get a 2x by a square and 2t dt and dx. So instead of dx, you can just write it's
And you can
cancelled.
skip the derivations part if you,
Yeah, that
because the formulas are available in the book.
yeah, it's available. So shall we just skip the derivation of this? It's
Yes, ma'am. We can, yes.
If
Yes,
you
ma'am.
really want to do the derivation part, you can try it on your own. It's just some manipulation in the
And could you please just rewind the process briefly of integration by parts?
yeah, sure. Let me just get done with these ones first. So these are the two that are there. This one, and then we've done this because we want to. If there's something in the integration, if there's something like this in the integration, you'll know that this is the integration of these things. That's why
Formula
we've written this.
1 by square root of a square plus x square.
Which one?
Formula of dx by square root of a square plus x square. That
Dx by what?
square root of a square plus x square.
X squared plus the.
Yes.
Is it x squared plus x squared?
X
Is
square
the
plus a square.
a square? All right. This is it's written here. Wait.
No, that is a square
It's
root of a
okay.
square
Okay.
minus x square, and without the square root a square plus a square. That is written.
So I don't think I remember the form. This is wait. You can do it by substitution too if you want to, and I don't think I remember the formula of this one. It's like I'll just write down all the form. The basics are these ones that I've written, and then there is this one too, which I haven't seen in the assignments though. It's x square minus a square. These things are there. Uh, yeah, this you can do by completing the square thing, I guess. You can't actually. This is you can try the substitution one on this one.
Okay, okay. And we can try
Should
by
I do it here?
we can try by ourselves.
Yeah, that'd be good if you could
I
just.
was just asking that if there is some way I can remember, because sometimes mistake is happening in question that I am mixing up formula.
It'll be good if you
I
could
don't
just
think
substitute it and just so that what some of us could learn.
instead of dx you can substitute dt by
Okay, ma'am, no
2x.
issue. You can if you like skip the derivation, we can.
But that's how you live. Because I don't remember if there is a formula to this. I don't remember it right now.
Okay.
And there's nothing that there are no questions in anywhere that need this formula, I think. So, and if
Ma'am,
there is,
it's
then this can be done by substitution.
ma'am, I know the value.
What is it?
Ma'am, it is ln mod x plus
Is it x plus a? No.
under root x square plus a square.
What?
It was ln mod x plus
Okay.
under root x square plus a square.
These formulas are there as well, the natural log ones, and then there's another one similar to this.
This 2 times whole
Yes.
I think was within mod. Means x plus square root of x square plus a square, that whole thing was within mod, I think so.
Yeah, this isn't, yeah. This whole thing isn't. These are not there in your assignments or anything. I don't think you
Okay.
need this one. There's a similar one which uses a negative thing as well. I think it's this one only. Yep, the x square minus a square one. These two are similar. I don't think there's any other formula there's that we've missed. And then if you're doing everything, then there's one more. This one. They're not. I was thinking of skipping these ones because they are not there in the assignments or anywhere. So is it okay now? I think we've covered all the formulas of this form. Almost all of them. There's still
Okay, ma'am.
some.
Thank you.
If there's still any left, you can just remind me here. I'll write them down too. Because right now I don't have the list of these formulas.
Before going to the
Another
next,
one,
just
which is
please remind briefly the integration by parts.
Yeah, sure. Yeah, sure. The integration by parts is this thing.
Because
You
in
have two functions
questions, I
here.
think it is required.
So you integrate u and then take the derivative of u and integrate. No, wait, I've made a mistake here. It's this thing. And then we have a dx again here. All we need is that we first integrate this thing and then with the derivative of this we integrate it again. Is this okay?
Okay, thank
And
you.
there's this one isolate rule too related to this one, if to know which function to take as u and which function to take as v. So this is the priority for u function. So if you see an inverse, this is inverse trigonometric functions. This is logarithmic functions. These are algebraic functions. Your x square and the polynomial things that you have. These are those. These are trigonometric functions, and then these are exponential. This is the priority order. If you see an inverse trigonometric function, you take that as u, no matter what v is there. Is that okay?
Okay, thank you, ma'am.
Okay.
Ma'am, can you just expand eyelet once again?
Okay, this is inverse trigonometric functions.
I've uploaded a question, ma'am. I mean, I don't know if you're taking up questions.
Yeah, we were supposed to take questions of week 9. We'll do it now.
Are we doing it now or later?
We'll do it now.
All right.
Logarithmic
So
functions.
I've posted it on the chat.
Ma'am, please start week 10, ma'am, because
There are still doubts from week 9.
ma'am, but
I have
week 10 deadline is
okay.
approaching soon, ma'am. Actually, within 3 days we have to submit.
I think it will be quicker if we just get done with the doubts first. Otherwise, because there are still doubts, and the week 9 is also a part of the syllabus.
Yeah, could you please discuss the GA questions 1, 2, 3, and 7? I have sent the message also.
You just tell me the question number. I don't think I can do that.
That's 1, 2, 3, 7, and 9.
1, 2, 3, 7, 8, 9.
Yeah, 7 and 9. Even 8 is also good.
First one is like, it's, how the function, so you know how to plot the functions, right? The x1, the mod x1, and the x square one. That shouldn't be a big deal. And then it's just the area. First ones, you don't have to do anything. You just have to integrate x. Which of the part, is there a specific problem in one of these? Because you just have to integrate these things. That's all. Who have had a doubt in this? What is the doubt? Because it's just simple integration. You don't even have to do anything.
Ma'am, what will be the integration of mod x?
Write it as, if it's mod x, and first you need to know where to. So you have to integrate it from -1 to 1. So you just write it as mod x is basically x and minus x, right? When you take x from here to here and when you take x from here to here. So what you do here is to integrate this, we'll divide it into two parts because it's divided into two fractions. This one -1 to 0 and then from 0 to 1. So from -1 to 0, the function is minus x. Integrate this and from here to here you integrate this. Is it okay?
Yes.
And the other ones are pretty simple. This is just basic integration that you have to do.
Yes.
I think it'd be easier if you can pinpoint what your doubt exactly is in these questions.
Practice assignment. Now, question number 2.
If
Week 9.
someone has a doubt in all
Yeah,
of these, yeah.
yeah. Yeah, I will work on the question 1 because I just checked whether they have uploaded the solution for GA. It is not been uploaded yet.
Okay, so you just need to know the solution.
Yeah, I have doubts in this thing, but for the question 1, I can. Could you discuss with question 2 and 3, please? Yes, ma'am.
Yeah, sure.
Yes, ma'am. Question 2.
Question 2, a cylinder of radius x and height 2h. Radius is it's x, right? And the height is h. 2h. To be inscribed in a sphere of radius. So this is for a cylinder. And this is for the sphere. The sphere you have r, radius. The set of correct options. The cylinder has maximum volume amongst all cylinders which can be inscribed when h equals to r. So this is your sphere. And you have to inscribe a cylinder inside it. It's a let's just find out the volume is given to be 2 pi x square h and this one it's 4 pi x h. To find the maximum volume of the cylinder, right? Okay, I'm not sure how this one can be done if it's about the integrals.
Ma'am,
Ma'am,
substitute.
there's a problem in the question is that it's not mentioned that the capital R, which is the radius of the sphere, it's constant or not. Like they should have mentioned it.
If nothing is mentioned, that should be constant because if nothing is mentioned, how can
Nothing is mentioned for x and h also. So x and h will also be constant.
Ma'am, we have to differentiate with respect to height, right? In this case.
Say you have to eliminate one variable.
Yeah, substitute x square as r square minus x square.
I'm not sure which approach to follow in this question. It is asking you to maximize this volume. So
Put a
Ma'am, it's from
r square
GA,
minus
right?
a square under root in place of x.
Ma'am, it's from
can't
GA,
tell
right?
any of you. Yeah, it's
Yeah,
from the
this
graded
is GA
assignment.
question.
Can I share my screen?
No, you can just, yeah, either we can do it in the next class, or you can just, if someone has a solution to it, we can do it. But you
Yeah,
can
I
just
have the solution. I mean, I
so
have
you
not
can just
written.
speak it, right? So,
I can explain it actually. It's like, see, it's not, I'm assuming that capital R, which is the radius of the sphere, it's constant, even though it is not mentioned. And H and X are variable, right? Now, we know from Pythagoras theorem that capital R square equals to X square plus H square, right? So we can replace the formula like volume V equals to 2 pi X square H. We can replace X square with that. And then we will have an equation like 2 pi h r square and 2 pi h cube. And then we can differentiate it to find the critical points, and then we can further differentiate it to find the maximum.
Oh, you're differentiating with respect to which variable?
I have replaced x, so I will definitely replace
okay,
like
hold on.
differentiate
This is
with
enough
h.
discussion. Let's just
Okay.
try doing it. You have to maximize this volume, and it's inscribed in the sphere here, right? So this is the volume of the sphere. Its surface area of the outer curved surface is given by, so this is not the, this in fact is not even the volume. Wait. This is not sure how to just do this to prove that the first one's not correct, because this is the height of this thing, height is there, and then you have r is the radius of the sphere, right? So it's this thing, r is here, and then it says if you can even say that it's, if your height is the same as the radius, then I mean, if you take the height of this cylinder, this thing inscribed inside it, you are not going to get, if you take this height to be equal to the radius, now this is not even, this will be smaller than what it already is. So that's not going to be the maximum volume here. Obviously, the first option is incorrect. And then maximum volume amongst all cylinders which can be inscribed by H equals root 3R. We can't keep eliminating like this. We need a formula for this.
Now we can use trigonometry or Pythagoras theorem.
This is R, this is H, and this is X, right? This thing is this thing is R, this thing is X, and the height is, okay, it's 2h, so it should be h here. So you'll get the x in terms of, we need to maximize this thing, and the constraint is, we have a constraint that it should be in the sphere. And we've not been given the, there's one on surface. It's x square plus h square equals r square. What were you suggesting? That someone was suggesting something to replace? Were you suggesting this thing?
Yeah, ma'am, I was suggesting it in place of x square. Yeah, that's correct. Now we can
Yes, ma'am.
differentiate this function with respect to h.
Yes, ma'am. I also
Yeah,
solved
right.
using this.
Or maybe there's one more better method, but that thing is not taught in the like course so far. It's trigonometry. I did it that way, but I didn't say it because it's not taught.
Then it's not given that if you do it this way, it's
No, we
because
can
it
get the
makes sure
solution
here.
either way. We can get the
Okay,
solution this way
okay.
also or with trigonometry also.
I just wanted to make sure that the other stair condition is included, that it has to be inside the stair, which I think is included because we're using this thing. Okay. Yeah, then you can just differentiate this thing, I guess. We need to find the maximum, right? So in terms of with respect to h to get the solution in. So you'll get r square h minus h cube. Then get the this is r by root 3. One of the options, right? This is how you, but it does not involve integration and all, right? Okay. So this is it. This is one of the correct options, and then you have been asked to maximize, I guess, the surface area too.
Yes, ma'am. Same process उसमें भी होगा तो R/√2
Okay.
आएगा.
You have to do the same there. Is this fine now? Whoever had a doubt in this one. Any other question from, do we have it there? The third one.
Ma'am,
For
practice
curves in the
assignment question
following.
number 4.
Can we do this one first? Because we started with the graded assignment. Let's just get done with the graded assignment first. Which of the curves in the following figures enclose a negative area? So the third one is pretty simple. It's just if you see something and it's clearly visible that the area is not even like this. The options are pretty evident because you have been given things like this. So it's obvious that the area here, the positive area is way more than the negative one. So this is going to, the positive thing is going to outweigh the negative part here. The total area is going to, the total integration that we get is going to be positive in the first option. And similarly in the second one, it's again, this one is going to be negative because this time negative side has a much more area, has much more area than the positive one. I hope you know how to do this one now. And seventh one, the estimated area obtained by dividing the interval into 3 subintervals of equal length and the left end points of the sub. This is for x between this. Obtained by dividing the interval into 3 subintervals of equal length and the left end points of the subintervals for height of the rectangle is in this is your 0 to 6 part and then divided into 3 parts. And these are the left end points then of each interval. And then this is just the Riemann thing here, right? So this is your function, and you just this is how you do it. This one, right? Fx star, and then you take the summation of these. So it's just put a 0 first, 0 here. You'll get a 4 by 6, and the function is wait. The function at 0 is 4 by 6, and the length is 2. Then find the function at 2. The length is Length is 2, so let's just take out the common length and then you get this thing. Is this fine? This is what you have to do in this one. Find out the value at 0, 2, 4, add them and then multiply by 2 because the length of each interval is 2. Then question 8, I guess, is in the
Excuse me,
doubts.
ma'am.
Yes.
Please explain the question 7 again. I don't understand
So
what happened here.
you've understood this part, right? That you have been given that the
Have
function's
you done
value has to be taken.
integration on the function fx?
No, we're doing because if you have been given these things, so it's pretty obvious that you have to use the Riemann thing that you've done, the Riemann sum. So Riemann, and you can have a lot of Riemann sums, right? Depending on what point are you taking in the interval and what partitions are you taking. So the partition is being given to you. The points are given to you. These are the points given. So from this interval, you should take this point. From this interval, you should take this point. And from this one, you should take this point. This is the formula, right, for the Riemann sum. So we've just taken the function's value at 0, which is this, function's value at 2, and function's value at 4. And then because the length of the interval is the same everywhere, it's 2 here, 2 here, and 2 here. So we've taken 2 outside common. Is that okay?
Ma'am, if you don't mind, can you use the white ink instead of red? The contrast is just not great on my screen.
Okay.
Thank you so much.
And then you have been given this function. It's not here. What's the global minimum of f on 0 to 20? 0 to 20, you just need to differentiate this thing, find the minimum here. So let's just call this f1, let's just call this f2. So you do f1 dash x, equate it to 0, and find the value of x, where this becomes 0. So if your x is in between 0 to 10, that means you have to include that point. Who had a doubt in this question? Do we have a doubt in this question? Because this is pretty simple. I want you to be a little involved so that I know what exactly is the doubt.
No, ma'am, no doubt in this question.
No doubt in this question, so we're skipping this one then, because you just do the derivative of these two things and then you equate it to 0, both of these things, and then the value of x from here and x from here should lie from in this interval, and in this one it should lie here. If it does, then you see where it is minimum. Let's just say you get an x1 from here, x2 from here, then just see which one gives the minimum value of f of this thing. I hope that's okay. And everyone understood this part. Then the last one's pretty simple too. So do we need to do this one? Does anyone have a doubt in this question? Find the least
No,
value of
ma'am.
2xy. Okay. Don't have a doubt here. Yep. So any other doubts from week 9?
Can you take 9.6 activity 8th question?
Nine point six, question 8. So 8th question is, we've been given a hint for it. This is it, right?
This 1 plus x cube.
Yeah.
Let's just have a look at x by 2. So we know that you can't integrate this one, right? Obviously, you can't find the derivative integration of this one directly. So what we do here is we compare x cube to, we've been given the hint, so it's easier now. So you compare x cube to and this thing is given to you. Just give me a second. There's a trouble on my end. Okay, let's just compare these two functions first and see which one's greater. So you have a minus x by 2 here and an x square here. So this is essentially the greater one here. Even if for one x greater than 1, this is true. For x between 0 and 1, it's again true, right? And for x between minus 1 and 0, it's not true, but we have been given the integration from 0 to 1, so we can skip this part. So the integration area from 0 to 1, this thing is true there. It's true for x between 0 and 1. And then if you'll add a 1 on both sides, you'll get this thing. And if you take the reciprocal, you'll get this thing. And then there's this one property where if the function is, let's just say for x in between 0 and 1, this function is greater than this function, then the integration of this function 1 by 1 minus x by 2 is going to be greater than 1 by 1 plus x square, 0 to 1. Just integrate these two things. 1 by 1 minus x by 2 integration from 0 to 1. So you will get a
This is which question?
natural log of. It's question 8 from activity 9.6. And then a negative thing here too.
Outside the 1 by 2 will also come, I suppose.
Yeah, let's just.
It's outside the.
Just write it.
Sorry, 2. 1. Basically 1 by 1 by 2. That is 2 will come outside.
Minus x and that is a and then you get a negative sign. A negative sign and the 2. Then you put a limit from 0 to 1. So if you put a 0 here, you will get natural log of 2 minus 2. And if you put a 1 here, you will get 0. So this is what you get. There will be a negative sign. Wait. Yeah, there will be a negative sign. This is what you get here. So the integration of this thing 1 by 1 minus x by 2 dx is this thing. And then the other one is 1 by 1 plus x square. If we'll integrate this thing, you will get tan inverse of x from 0 to 1. So tan inverse of 0 is 0 and tan inverse of 1 is pi by 4, right? And we know that this area is minus 2 natural log of 2. And this one is pi by 4, right?
So f of x is less than 2 no?
Ma'am,
Is there a confusion? Yes.
I think like this question can be solved with like partial fractions, but it's not taught in the lecture.
But we don't need to do the unnecessary things here. Partial fraction is not needed here. And yeah, it can be the one, you can just write it as there's an identity for x cubed plus 1. Then you can use it here. and then you can use the partial fraction, but it's not in the syllabus, I guess. So there are other ways to do it. You can do it by that way too.
I mean, you
Partial
could still
fractions.
use it to solve it, right?
Yeah, yeah. When if it's just the MCQs, you can use whatever. If it's not the MCQ, then maybe it will matter what you're doing. But if you're able to get the right answer, I don't think it matters. So our
I mean,
options are,
either way, we would get the same answer, right?
yeah, it gives the same answer. That's why it's a formula. So these two, I hope we have not made a mistake while calculating these two integrations. So this is -2 natural log of 2 and this is 5/4. And then our options are 0 to 1, 1/1 plus x cubed. So what we can do here is we can compare 1 plus this thing with one of these so that we know. So let's just see which one's greater from these two. So -x/2 the same way is less than x cubed for x between 0 and 1. So if you do a 1 here, it won't change the inequality and it would get changed if you do this thing. But this area came out to be -2 natural log of 2, I guess. I think we made a mistake here in this. There should have been something else because it's not in the options.
It's given
How
plus
can we
2
solve
dot
that
here.
integration without like partial fractions?
Partial fractions in the x cubed. We're talking about this. We don't use a partial integration here. Have we made a mistake in this one? Let's just do this one again then. 1 by, we'll integrate this from 0 to 1 to get a 2 minus x dx and a 2 here. And if you substitute it to be t, you will get 2 minus x equals t minus dx equals dt. Yeah, you get a negative sign here. Minus dt, a 2 here from 0 to 1. So this is natural log of t with -2. 0 to 1. We didn't change the limit here, no? So 0, if we'll put here, we'll get a 2 here. And yeah, that's the mistake that we made. And if we'll put a 1 here, we'll get a 1 here. We didn't change the limits here. So it will be 2 and 1. This you will get as 2 natural log of 2. So you get a plus sign here. So this option is true if it's there. This is one of the correct options. And then you compare. We have this has been a little messy as to how we've done this, but it's clear to everyone how we've got.
Yes, ma'am.
Had the doubt in this. Is this clear?
Yes, ma'am. It's clear.
You have been given this thing in the hint. So you just, and you can integrate this thing. The integration of this thing is this. And the integration of this thing is this. And we know that the function is, we're using a property here. Should I list the property? If your f is greater than g in, say, D domain, and this thing is going to be greater than g if you're integrating it over the domain D. Is this okay? This is what we're using here. Is it clear to everyone? Similarly, you can do the other part where it's 5/4. Is this clear? So moving on to the next question then, if this is clear. Okay, any other doubts from Anywhere. Week 9.
Practice assignment
Ma'am, one
question.
practice assignment question number 1.
Okay.
That's a graph question. If you can take the picture on directly on your screen, then it would be helpful for other students too.
I don't think I can share that screen right now because I'm just sharing this one screen that's visible. So
No problem, ma'am. You can discuss
you can
directly.
just have a look in your grade, the practice assignment that you have. Which question is it?
Practice assignment question
No, I
number
have a
1.
doubt in question.
I have posted that question. Sure.
You can just, if it's from the practice assignment or anywhere, you can just tell the number. That'd be better.
Ma'am,
Because
question
I
number
anyway
1.
can't. Question 1. Whoever's posted it, you can just tell me the question number.
That was the like last one which was uploaded, right?
Okay. So you've been given some function. You have to map them to their graphs. And okay, is the graph thing, how we make the graph of things, is that part clear to everyone? How we plot the graph of these are like pretty standard forms. So is it clear
Ma'am,
how we make
standard
the,
form, excuse me, ma'am.
yes.
Ma'am, the standard forms like e raised to the power x, ln x, or x square, x cube, x raised to the power 4, these are clear. But when it comes such type of graph, I can't do. Please explain this first.
This one or which one is it?
Ma'am, the x cube is clear. Like you are asking the theory behind this. X
Okay,
cube we know 5x minus 1 is also known, but the 1 upon x square plus 1, like such questions.
So the left one, this one is obviously the third one which is left is to be mapped to the left part, no? The part that's left. So the B part is left, it will be mapped to be the graph of B.
No, ma'am, if the examples are changed, we have to.
We don't have a proper graph for this one. If you're talking about that part, then what will be the graph of this thing?
Okay, we are just putting the value and then.
No, we're not putting the value. We know the graph of these two. And the left one will be the graph of this one, obviously.
So ma'am, I am asking that can we create the graph for the third option or it is not possible?
What? I don't think I understood your doubt. What's your doubt?
Ma'am, the question first, please explain by taking one example.
The first question you're talking about, right?
Yes, ma'am, yes.
You just have to plot it. You first we're talking about the graphs of these. We have to map them to the graphs. So you know the graph of this one. You know the
Yes.
graph of this one too. And then the left one is the graph of this one, right? The one that's left.
Yes.
Ma'am, how are we so sure that the last graph could be this one? What if they
There are
give
only
two
three options.
questions? No, ma'am,
There are
be it
only
some
three
other
options,
question.
right?
Ma'am, be it some other
You won't
question.
be asked
If
a
they give,
question of, you won't be asked such questions to plot the graph of this or to identify the graph of this.
so there is no possible way that you will be able to explain how to get the graph of it.
There are ways to it. There are a lot of things that you look at, like the asymptotes and everything that you have to map to plot a graph, but then it's not there. I don't think you'll be asked that.
Excuse me, ma'am. Can I
Yes.
ask? Ma'am, by giving these option, we can check. And then
And one
in
way to do
another
it is if you
box.
really want to figure it out, if you have been given something like this, is you can find the x-intercept, y-intercept, that's what I was talking about. There are other ways too. One is you can obviously see the x-intercept and y. So if you substitute 0 here, you'll get y equals 1, which you can see is true in this case. You have been given some sort of this graph and it is this only. This point is 1 only. And then if you'll put y equals to 0, which you can't obviously, if you'll put this thing to be 0, there's no value of x that gives y equals 0. So obviously this means that it doesn't touch the x-axis. That's one way to figure out and see this can be a graph of this. You can't exactly plot the graph of this.
Okay, ma'am,
that okay?
understood. Yes, ma'am.
Okay.
Ma'am, the second part here given is the area, how the pi by 2 area is given. Can you please once check the question again?
Okay, for the last one, the graph that looks like this one, obviously it's the 0 area, right? Because it's pretty symmetric about this one. So this one's positive, this one's negative, it gets cancelled out. So this one is 0. And then
Okay, ma'am, then the first one is also similar looking now. It's just a simple curve. It is also
and just integrate this. It's not the same thing. It's if you look at the other one, it's okay. When you just integrate this part, you'll get this thing x square minus x, and then you have it from -1 to 1, I guess. So this isn't.
ma'am, here it is not defined -1 to 1. If we can check the graph
It
and
is
then
given.
we
The
can show,
interval is given -1 to 1.
or maybe my mistake. Ma'am, no,
It's given.
I'm asking about the areas, the how you surety, how we get surety about the area 0, pi by 2, and -2.
Okay, just forget about the graph for a minute. You can just integrate this thing. So if you have been given a graph, so you can just integrate that thing and then put the limits here -1 to 1, and then you will see what the area is. Is it
Ma'am,
fine
it
now?
will be value now, it will never be pi by 2. In any case, if
In
the
this
interval
case,
is
this is not
-1
going
to
to be
1.
okay. This 1 by x square plus 1 you have, right? This one. The integration of this
Yes.
is tan inverse, right? So
Yes,
in
ma'am.
this case, if you are, that's why if you're well versed with the formulas, no, you know that this is tan inverse, and this is the only way where you can get a pi by 2.
Ma'am, tan inverse 1 is pi by 4.
Okay, this is -1
It
to
will
1.
never be.
This is pi by 4, right? This is 1, and this is tan inverse of -1. This thing is pi by 4, and then this thing is minus pi by 4. So it's plus pi by 4, so it's pi by 2 here. Is it fine now?
Okay, ma'am, now fine. I was not doing it correctly. Thank you, ma'am.
It's all right. Other doubt from this practice assignment?
Excuse me, ma'am.
Yes.
Ma'am, if anybody don't have a problem, in last 10 minutes, please discuss the Riemann sum once again.
Yeah, sure.
If you can. I am facing a lot of problems. I am not able to solve directly by formulas.
Okay, we'll do it here towards the end. Any other doubt from practice? Any other doubt from anywhere? First, let's just get done with the practice assignment thing. Anyone has a doubt from there? Does anyone have a doubt from anywhere in week 9?
Ma'am, practice assignment question number 4,
Which practice assignment?
week 9.
Okay. So practice assignment. Okay. We were discussing question 4, right?
Yes, ma'am.
So you know what left Riemann sum is, right? Left Riemann sum, right Riemann sum, and middle Riemann sum is also there.
Ma'am, I
So
don't
it's just
know.
okay. So if the Riemann sum is basically you'll be given the intervals obviously, and you'll be given the subdivisions too. So in this case, it's 1 to 10 in the first one, and then it says that it's divided into into 3 subintervals. So it's 10 by 3, uh, then 10 by 3 plus 10 by 3, which is 20 by 3, and then it's 30 by 3, which is this. And then the function is given to be this thing. We're talking about the left Riemann. Left Riemann means, so in the Riemann sum, you pick a point where you calculate the value of function, right? This thing. We take the Riemann sum as this. So you pick a random point from this interval and from this one then. So this random point is given to be this time because it's the left Riemann sum. The left Riemann sum means the leftmost point is to be chosen. So this one you choose, then this one you choose here, and from the third one you choose this. For the right one you choose this, this, and this. And for the middle one you choose the middle point of all of these. Is that okay? And then there's nothing left to do. So you just have to put that point here. So if it's left Riemann sum, you can do F1 and 10 by 3 plus F10 by 3 into 10 by 3 and F20 by 3, 10 by 3. Is this fine?
Sorry, it's not clear. Could you please repeat that?
Do you have a doubt in this thing?
Yeah, this thing from the function part, yes.
Excuse me, ma'am.
Yes.
Can't we put 10 by 3 is equal to 4 and 20 by 3 is equal to 7? Their gap difference is equal to 3 yet.
What?
One leftmost one and then 4, then 7, then 10. Yeah, there.
What are you trying to do? 1, 4, 7?
Yes,
Are you
ma'am.
trying to partition it as 1, 4, 7?
Yes, ma'am. Delta x is in all case delta x is equal to 3. So yet we can do it. That will be easy.
Wait. On the interval 1 to 10. I think we've.
Yeah, I solved it
I thought it's
using
0 here.
147.
I thought it's 0 here. Wait.
No, ma'am. I solved. It's 1, 4, 7,
Okay, then
10.
this partition is according to 0. That's what I'm saying.
Yeah.
Because if you divide it, there's only one way to divide it into 3 equal parts. So it's 10 minus 1 and then it's 3. The length of each interval
9
is
by
3.
3.
Yeah.
Yes, ma'am. So 4 and
So it's
7.
4 here.
The third
1
one.
plus 3, 4, and
And
then 7. Yeah, right.
then it will be easy.
That's the only way to do this question. What we did earlier was wrong. I thought it is 0 here. So if it had
Yes,
been
ma'am. 10
0 here,
minus 1. 10 minus
then
1.
this would have been this thing. So this is, don't partition this thing as this. The 3 equal partitions from 0 to 10 is this, and 3 equal partition from 1 to 10 is this. Only this is the only possibility to divide it into 3 equal parts.
Yes, ma'am.
Okay. Thanks. So it's changed this thing here. It's 1 here, then it's 4 here, and 7 here. Is this fine now? Do we have a doubt here, anyone? I think now you should be able to do this question, the fourth one. Or do you want me to completely do this thing?
And we can do this.
Okay, let's just do
You
this
can
one then. Let's just take 10 by, then it's not 10 by 3 either here, because it's 3. So let's just start from the start. You have 1 to 10 and you have to divide it into 3 equal parts. So what you do is, the easiest way is you just take the length, which is 9 here, and then you divide it into 3 parts, so you'll get a 3. So the length is 3. Each sub-interval should have a length 3. So you take the length 3 from here, which is 4, 3 from here, which is 7, and then it's 10. That's how you divide it into equal parts. And then all you have to do is, you just have to remember this formula, which is the delta xi. If it's confusing you, it's basically this thing only. Xi minus xi Yeah, xi plus 1 minus xi. This is xi, this is, let's just say x0, x1, that's how you, if that's how you partitioned it. Then this starting from x0 and this is xn. So I will vary from 0 to n minus 1. Is the formula clear? What you do here is you take this length and then you multiply it with whatever point you take here. So this xi star point could be anything. It could be this point, it could be this point. You find the function's value at this, and this is always given to you. So this point will be given to you. As in this case, it's given, it's the left Riemann sum. So in the case of left Riemann sum, is this much clear to whoever had a doubt in Riemann sums? We're discussing Riemann sums right now. Is this part clear? This much, the formula part.
Yes, ma'am. Yes, ma'am.
Okay. And then the left, I hope the left Riemann sum and right Riemann sum, middle one, these are also clear. In this, the particular case, you just take the left thing. So, you know, your xi star could be anything in this interval.
Excuse me, ma'am.
Yes.
Ma'am, please explain this once.
This, the formula?
Yes, formula and the left Riemann sum especially.
Okay. So what you do here is, let's just say you have this function and you have been given this interval a to b. And this is the partition, say, x0 and this is xn. And here you have an x1, then an x2 and so on, so on. These are, let's say, the partitions. So what you do here is, you take a point from here. Let's say this is, you're choosing this point, and this will be given to you in the question. You don't have to worry which point to take. This is we're calling as x0 star. So you take it here, and then you find the value of function here. F x naught star. And then what you're doing here is you're multiplying this length with this height. So basically you're finding the height of this rectangle. Is this okay? Similarly, you do the same thing here. You pick a point here, then you take the height here, and say this is
Yes,
the height.
ma'am,
So
this is okay.
you're multiplying this thing with this. So you're getting these areas, the rectangular areas. That's what we're doing here.
Yes.
Is this formula clear now?
Yes, ma'am, it's completely clear. Formula.
Okay. And then now you've been, for the left Riemann sum, what you do is, let's just say you've been given this thing. Let's just say you've been given this thing. So for, you have to pick a point, you have to pick xi star, right? So now this xi star is this point. For the left one, it's this. So you choose the leftmost point. This is the leftmost point in this interval. Can you see this? This is the leftmost point. This is the leftmost point here for this interval. And for this interval, the leftmost point is here. Is that okay? So the xi stars that you have to choose in the left Riemann sum is these leftmost points you have to choose. For the right one,
Yes, ma'am. Okay.
the right Riemann sum, you have to choose the rightmost points of the interval of the division partition. Is that okay? And for
Yes,
the
ma'am.
middle one, you have to choose the middle point, this one, the middle of the interval. That's what left Riemann, right Riemann, and middle Riemann sum mean. Okay,
Yes,
should we
ma'am.
still calculate this thing? The function was x plus 5. So if you put a 1 here, you'll get 6, 3. If you put a 4 here, you'll get 9, 3. And a 7 will give you 12. It's 18 and 9 is 27, right? So this is 27 into 3.
Yeah, total is equal to 81.
It's 81. This option is correct. The same thing you have to do with other options. Is that okay? Any other doubt from the practice assignment?
And ma'am, what
Excuse me,
can we
ma'am.
do if they are middle Riemann sum?
What is the doubt? I can't hear
Ma'am,
you.
middle dimension.
In the middle one, the partition is this, right? 0 to 4 to 7, then to 10. So just find the middle of this. No, in this case it's 2. 4 and 7, you just add these two and then it's 11 by 2. Then these two, 17 by 2. Is that okay?
Yes, ma'am.
You just choose these points as this is x1 star, this is x2 star, this is x3 star. The star points that you take in the formula, just take these. So in this case, you will calculate this f2, f11 by 2, and f17 by 2.
And ma'am, what will be delta x?
Delta x doesn't change. It remains same. It's 4 here. Everywhere it's
Oh, but
it's
we
4,
have to
right?
take
No, it's
middle
3.
value only.
Yep. Only the wait, we've taken this wrong again. It's 1 here and 3 here. This doesn't, I mean, you're not changing the partition. So your delta xi is basically the difference between these 2 points, right? If you don't change the partition, the delta xi is not going to change.
Okay. Yes, ma'am. Now it's clear.
Okay. Any other doubts from this week, from practice assignment, from anywhere?
Ma'am, I have in 10.1.
We have not discussed 10, so the 10th week yet. Not even done with the summary. Okay, we'll take it towards the end. Your 10th doubt.
Excuse me, ma'am. Ma'am, can I ask some theory doubt?
Yeah, sure.
Ma'am, in week 9, there is a term called mesh on basis of the Riemann sum. The max of
Mesh,
del
it's,
x.
I don't think you'll be asked it, but mesh is basically the maximum of part. It's this, right?
Yes, ma'am.
This is basically maximum of. Yes. What's your doubt?
Ma'am, my doubt is you are saying the del x is same, and then how we are able
No,
to
it's
find?
not same. It's not always same. In the questions, in the question that we were doing, it's given in the question that it's the same. We're dividing it into 3 equal subparts. That's why it's the same here. Otherwise, it doesn't have to be same. It could be this partition could be anything, right? If you take from 0 to 10, you can take 1, then 3, then 6, then 7, then this thing. So this is not equal. You can still partition it this way. So in this case, the
Okay,
mesh
ma'am.
will be this is
Basically, the
maximum of all
maximum
the the
interval between
maximum,
two.
not the interval. It's actually the length of the interval. Maximum interval length.
Okay, ma'am.
Okay,
Thank you, ma'am.
you're welcome. Any other doubts? Is there any other doubts from the week 9? I'm assuming there's no doubt from week 9. So someone had a doubt from 10.1. Although we've not discussed 10th week yet, but let's just see what your doubt is.
In 10.1, question 4.
Just give me a second. 10.1, question 4. It's we don't have a doubt from week 9. We'll just wrap it up after this question because we're not left with enough time to discuss week 10 summary here. Are there enough people to discuss week 10 summary?
Ma'am, are you gonna extend this session or It is just
If there
the
are not
time.
enough people, because a lot of people wanted the summary of 10 to be discussed
Yes, ma'am.
today, but
We
they're
can
not
wait.
here right now, I think.
Ma'am,
Yes,
there are
ma'am. So many students are waiting in
Ma'am,
starting. We can wait.
So we can extend the session, but I don't think we still will be able to finish week 10 today. So if
Ma'am,
other
as
people
you
want to join,
choice.
if they want to join, they can join. We can discuss 10 some part of week 10 today, and we'll have to do it tomorrow too.
Uh,
Ma'am, if you can do it, then please, it's a recording session. It is completely your choice. There are 21 students in the class.
Okay, we'll just after this thing, maybe we'll discuss week 10. So if we have to discuss, okay, let's just do this question first. This
So
is a
are we
directed
doing
graph.
week 10?
Yes. This is a directed graph. I hope I've made the graph correct. So this is, now what's someone had a doubt in this question. For this, we'll need to discuss the summary because it's a very simple question, just asking you if it's a directed graph or not, if it's an undirected graph or not. It's clearly a directed graph because it has directions.
ma'am, what happened was that V7 is reachable from every node. I also marked V4 is reachable from every node, and I got that wrong. So what I didn't understand is if V7 is reachable from every node, then why is V4 not reachable from every node?
Okay, let's see.
Ma'am, there is a arrow
V
between
V8 is
V4
not
and
connected to
V6
V4.
also.
V8, you can't reach,
V4 from V8.
yeah, you can't reach V4 from V8, right?
Oh, okay, okay.
Okay. So
But what I was like from V8, can't you like take the long route and reach V4? Because V7 also, if it is reachable from every node, we are doing it via the other nodes, right?
okay, see, V7 is here. So if you start from V1, it's reachable, right? Because it has arrows till V7. From V2, you have an arrow here, then here, then here. So it's reachable from V2 as well. So I think it's reachable from everywhere. It's reachable from V0 as well. Because it is extremely important to note the arrows. But when you look at V8, V8 is not reachable from V4. But see, V7 is reachable from V4. If you go from here, we
But
visit
if we
V01.
take V7, V9, V6, and then V4, it is reachable, right?
You're checking if V7 is reachable from V4 or not, right?
If
What
we,
exactly are you checking?
ma'am, when you say V7 is reachable from every node, you are seeing that if the arrows, the direction of the arrows is going to a
Yes,
node, which is again taking it to some other node, which is reaching V7 finally, right?
V7, if you want to reach, this means if you start from, say, Vi, then there should be other Vj not, then
Right.
Vj1, and finally you should reach them. That's what it means. So V7 you can reach from everywhere, I think. I've not checked all of these vertices, but you can. And V8, I think you can't reach from V4. It's because yes, you can't, because if you go, there's only one way. This way is
I think I
where
got
it
it.
connects to. Okay. So
Yeah.
in fact, it can't be reached. You can't reach V8 from V9 either, not from V7. You can't reach
Correct.
it from a lot of vertices. So It's not
Even in
reachable.
that
And
case,
then V4,
if I understand, sorry
yes.
to interrupt. Even if I understand right, based on a figure that you had drawn from V7, it's actually the direction is from V8 to V7. It's not from V7 to V8. Am I right?
Yep, it's not backwards. That's the
Yeah.
main problem here. So V4 is not reachable because you can't reach it from V8. That was our main thing. This is not reachable from V8 because there's no backward arrow here.
Thank you, ma'am.
Okay. So it's just so shall we discuss a bit of the graph theory part here?
Yes, ma'am.
Starting from, I think everyone who's here is a bit okay. Let me start with this. So you represent your graph with this notation, where this is a set, this is also a set. So this is collection of vertices. I think I'll have to discuss it again tomorrow because there are no people in the meet. Okay, I'll just do a little bit of it today because it's anyway a long thing. These are vertices which are like pointed as these things. These are called vertices, and then these which join these points are called the edges. So this is your vertices set, and then this is the edges set. If this is V1, V2, V3, and V4. So edges are joining V1 and V2, then V2 to V3, and these are your edges, right? V3 and V4. And then after this, we have directed and undirected graphs. The directed graphs are the ones with directions, as we have seen. This one is an example of directed one. Then we have undirected graphs. Directed graphs looks like this, where you have a specific direction. So this means you can go from this vertex to this vertex, but you can't come back from V2 to V1. That's not possible here. This is what a directed, and if you look at the real life example of a directed graph, it's basically the aeroplane thing. So if you are at an airport, say, so some airports do not have flights, direct flights. If this is an airport, this is another airport, and this is another airport, say. So you might not have a flight from V1 to V3 directly. So you need a direction for this. This is if there's a flight from V1 to V2, but not from V2 to V1, then you need a direction, right? So that's for the directed thing. And for the undirected part, you don't have directions. So you just directly connect the things like this. And then we have the some common problems on graphs and all. So the first one is your graph coloring problem. So in the graph coloring problem, what we do is, so why do we use graph coloring thing? It's basically to identify that no two vertices are colored. Let's just say these are four vertices here, and you want to color these vertices in a way such that no two adjacent these are called adjacent vertices. I'm summarizing everything because so V1 and V2 in this case are adjacent vertices because they have an edge. Any two vertices which have an edge are called adjacent vertices. So these are adjacent things. So you can't color the adjacent ones with the same color. Let's just say you're coloring this green. You can't color this one green. You have to pick another color, red. And you can't color this green, but you can color this red because there's no edge here, right? What we're trying to do is we just want to make sure that the adjacent vertices are not colored with the same color. So you can color this one red and you can color this one green. So this just solves your problem that no two adjacent vertices. How do we use this in real life? Let's just see an example of a real life example based on it. So let's just say you have an exam like you used to have in your schools. So, and then there are subjects, different subjects. So if you are from the same stream, let's just say you're from the science stream, so you can't have, because if a student, if a student, because if you have, you can't have the paper of physics and chemistry on the same day, right? Because if you have the paper of physics and chemistry on the same day, people, there's a choice of choosing physics and chemistry in almost every school. So if your school offers physics and chemistry together, you can't have the exam of these two subjects on the same date. So you'll have to have them on the, so let's just say we need to find the minimum number of dates, yeah, minimum number of days to conduct exam for 12th standard, let's just say, for grade 12. We'll have to make sure that physics can, so we can put the exam of physics and let's say business studies, because this is not a popular choice in many schools. I mean, I don't think schools offer physics and business studies together. So if we're going with the basic science stream, then commerce stream, non-medical, medical, and then all of those things. So you just want to make sure that the subjects that can be opted together are not on the same day. The exam for those subjects is not on the same day. So what you do here is you're using the graph coloring problem here. So let's just say you have subjects, physics, chemistry, maths, and then you have business studies, economics. So what you can do is you can do the maths and you can do the maths and this exam together, right? Let's just say they're all connected to each other. See, what we're trying to do here is you can have the maths and economics exam together, but you can't have the other subjects exam. You can't have physics and maths exam together because that's a choice. So what you can do is you can color maths with one color and then you can't color physics with the same color. Is this understood? Okay, I need to know if this is understood, the example is understood or not.
No, ma'am, the subject, this example is not, I understand.
Okay. This is, let's just say, this is chemistry, and then you have business studies, then you have economics, and let's just say they're all connected to each other. So what we're trying to do here is we're trying to find the number of days you'll need to get done with all the exams. But you can't, so you can color this as something, let's just say we color this green. But now I can't color this. So what you do is these are your subjects, and what are these edges? These edges are if students have opted, so there's an edge between maths and, okay, let's just draw this properly. There'll be an edge here, there won't be an edge here. There can be an edge here. Okay, this is fine. I've not written all these subjects. So what this does is, I hope this graph is clear, because when you have the vertices here are subjects and the edges here are, if two subjects can be opted together, then there is an edge. If they cannot be opted together, then there does not have an edge. Business studies and maths is also maths is offered in commerce, so that means it's not a confusion as to which subject is offered in what stream, right? Is this a confusing example? Let's just say you have geography too. So geography is not offered with maths, but it can be offered with economics. And then you have, let's say, Hindi too. So Hindi is offered with geography. It's offered with physics, chemistry, maths too. So this is what we're doing. Is this graph understood?
Yes, ma'am.
Okay. So what we'll do here is now we just want to make sure that we know that if there is an edge between maths and chemistry, we cannot have the paper of maths and chemistry on the same day, because they are common students, the students who have opted for maths and chemistry both, right? So we can't have the exam on the same day for maths and chemistry. So what we do is we'll color this thing, say we are coloring this green. So we can't color this thing green. That's what our idea of graph coloring was originally, right? We can't color the adjacent one the same color. We can't put the green color here now. We can't put the green here. because you cannot have the exam of these two on the same day. Is that okay?
Yes.
Okay, ma'am.
This is our problem. What we're trying to find is the minimum number of days to conduct exams for grade 12. So we're not mentioning the all the subjects here. We're just mentioning these. There are obviously a lot of other subjects too. So if you have the vertices are subjects here, and the edges are there is an edge between the two subjects if there is a student who has opted for both maths and physics. And there's an edge. So there's maths and geography is not offered together. I mean, it can be in some schools it's offered, but majorly most of the schools maths and geography are not offered together. So there's no edge between maths and geography. There's no edge between maths and Hindi. Yeah, let's just call this one history. Let's just remove this edge too. Physics is generally not offered with history. Physics and history are not offered together in class 12. So this is it. And we need to find the number of, so if maths exam is on say some date, you can't have the physics exam on the same date. So this is say we're coloring this green for say 1st of January. So all the subjects that you can conduct on 1st January, we'll color them green. So you can't color physics to be green because you can't have the exam on the same day. That's how graph coloring works in real life problems. So you'll have to pick another color. Let's just say we pick red here. And you can't pick the same color as green and red here. So we'll have to choose another color here. So it's blue here. And then for the business studies, you can't have green, but you still can have red. So which would mean that on, let's say this green is 1st Jan, red is 2nd Jan. So you can have the exam of business studies and physics both on 2nd Jan because they are not offered together in the school, in the particular school. So is that okay?
Yes.
Is this much clear?
Yes.
And we can color this thing we cannot color red, can't color green. So we'll have to pick another color. We can color it blue. Because again, chemistry and economics are not offered together. So there's no problem. So blue says 3rd January, you can have the exam of economics and this chemistry on the 3rd Jan. And then here you can pick any color. You can pick green here, you can pick blue here. You can even, no, you can't pick blue. So green and red you can pick here. Let's just pick red here. And then here you cannot pick red, so you can pick blue here. So if these are because you have only these, so you can get done with these things in 3 days. Is that okay? So require minimum 3 days to get done with all these subjects. So the answer to this is 3 days, if only these subjects are offered. Is this okay? Is this thing clear?
Yeah.
Yes, ma'am.
Okay. So that's how you identify the graph problem. So if you see any graph coloring problem, it will look like this. And then we have another problem, which is the vertex cover problem. Vertex cover is basically, what is vertex cover? It's a subset of V. So V is a set of all the vertices. This is a subset of V, that's the vertex cover. But which type of vertices do we collect in this vertex cover thing? So we collect the vertices here. So let's just say we'll do it with the example of a graph. Let's just say we have this graph. So if we have this graph, vertex cover is basically you collect the minimum number of vertices here or all the vertices here, such that if you put that vertex here, for every edge there should be one vertex here. So this is collection of all the vertices such that for every edge that's in the graph, there is one vertex here, at least one vertex here in this collection. So for example, in this edge, we want one of the vertices to be in this. This is the first edge, let's say. Let's just keep V1. And then from this one, you need at least one vertex to be here. So let's just take V3. From this edge, you need one vertex here. Let's just take V4. And this is, you need one vertex here too, but V3 is already there. So this is it. This is your vertex cover. Is this fine? You can choose another vertex cover too. That's not a problem. You can choose V2. From this edge, you can choose V2. From this edge, V2 is already there, so you don't need to choose V3. Then from this edge, you can choose V5. And from this edge, you can choose V4. Is this okay? Is the vertex cover thing okay?
The second part I didn't get, because like from V2 you are jumping to V5 directly without V3. How can you cover V5 without depending on
Okay.
V3?
Let's just make the definition clear. You want the vertices here
Yeah.
such that when you pick any edge, or any of these edges that are there, you have at least one vertex on that edge in this set. So if you have this set, say, let's just pick this one first. So you have V2 here. You want out of V1 and V2, you want one of them to be here. So V2 is here. Then from V2, V3, there's an edge here. You want one of them to be here. So you have V2 here. Then from V3, V4, you have V4 here. And from V3, V5, you have V5 here. Now I don't want one of, even if it were, let's just say there's no edge between V1 and V3. So you don't have to pick one from these two. Is that okay?
Okay.
If there were an edge here too, then it would have been necessary to pick either V1 or V2. Then only this would have been valid and this would have been not valid for the vertex. Is that okay?
Okay.
Okay, let's just wrap up the class here because there are not much students and
Tomorrow
no
you'll be
one's
taking the
responding
summary
either.
again. Tomorrow session you will take care of summary tomorrow. You'll be
Yes,
discussing.
it's a summary session tomorrow. For
Okay.
week 10. Okay.
Thank you. Thank you.
We wrap up the class here.
Have a night.
Thank you.
Okay, bye everyone. You're welcome. Bye.